Section 8. This is about after the proficiency test and the uses of samples that remain. So this is about the difference between a QC sample, a reference material, or indeed a certified reference material. For many of our products, we've made available the samples after the proficiency test for quality control purposes. It enables laboratories to troubleshoot performance or simply to use it as an ongoing mechanism for quality control outside of the formal PT process. The data for QCs are derived directly from the proficiency test. We advise on the stability, but the stability is not formally tested, and we do not provide measurement uncertainty. It's just the PT data for that sample. A reference material is different. In the case of a reference material, we're using some of the proficiency test data, but providing a measurement uncertainty value with it. This is not the performance limits of a proficiency test, but it's the variance around the reference value that indicates its accuracy. So it has purposes beyond that of a QC for example, calibration of a method. Where does the uncertainty U derive from? We provide an expanded uncertainty, which is the sum of a number of different sources of uncertainty. The components combine the uncertainty of homogeneity, the uncertainty of stability, and the uncertainty of the reference value. This is a considerable piece of statistical work to do. It's an expanded uncertainty, which means that we provide a coverage factor based on 95% confidence limits. For simplicity, the coverage factor equals 2, so the expanded uncertainty is the uncertainty multiplied by that coverage factor. This is standard practice across the majority of analytical chemistry. You can see in this example that the expanded uncertainty is 1.1 compared to the standard deviation for proficiency of 2.68. That means the uncertainty of the reference value is much closer and with a tighter boundary than the performance limits, which represent the required reproducibility of an analysis. They are different statistics. The uncertainty gives you an improved accuracy, traceability, it's more useful for calibration, it's a defined confidence limit, and we also provide the datasheet with a confirmed stability. We provide that based on formal stability experiments, and it's not the same as a reproducibility performance limits. We provide reference materials. These are not certified reference materials, CRM. For all practical purposes, the Fapas reference materials adopt the same principles as if they were certified, but we do not have the certification process in place to call them certified. That is the only difference with our products. That's the end of this webinar on principles of proficiency testing for analysts, and it remains for me simply to thank my colleagues in Fapas and the customers without whom I wouldn't have any data to share with you, and thank you for your attention.